Alright, so we're back to video number 4 for the Unit 6 review packet. These are the review problems on the law of sines and law of cosines. So what you need to do for the law of sines and law of cosines, we're just going to go through one problem. If you have any questions, just let me know. But alright, so starting off, problem number 1, this is section number 5. Yes, section number 5. So we're trying to find all of the missing sides or angles that we do not have. So first thing, we read the problem. It says in triangle ABC, the measure of angle A is 86 degrees. So triangle ABC, ABC, opposite of side A we know is going to be, opposite of angle A we know is going to be side A, opposite of angle B we know is going to be side B, and opposite of angle C is going to be side C. So we know that the measure of angle A is 86 degrees. We label that on our triangle. A is 37 degrees, 37. So side A is 37, and side B is 30, which is directly across from angle B. Great. So what pieces of information are we missing? We're missing angle C, side C, and angle B. Well, we have to ask ourselves, all right, what do we have, and are there ways that we can find the missing pieces of information? Well, I see that we have an angle, and we have the side that corresponds to that angle. So if we have an angle and its corresponding side and another side, we can use the law of sines to figure out one of the angles. So the angle directly across from the side that we know. So let's use the law of sines. Sine of A divided by A is equal to the sine of B divided by B. Sine of A, sine of angle A, say sine of 68 degrees, divided by side A, 37, and equal to sine of B, angle B. Do we know angle B? No. Divided by side B, which is a length of 30. So now we have to just solve for angle B, because we have all of the other pieces of information already given to us. Multiply by 30 on both sides. So 30 times the sine of 68 degrees divided by 37 is equal to the sine of B. How do I get B by itself? Well, I know that this is a function. Sine of B is a function. In order to undo the work of a function, what do I have to do? I have to take the inverse of that function. So I'm going to take the inverse sine of sine, so they cancel out. Well, if I take the inverse sine of the other side, I'm going to have to plug it into my calculator, and now I have my answer for angle B. So the measure of angle B is going to be equal to the inverse sine of 30 times the sine of 68 degrees divided by 37. So let's go ahead and do that. So what I want you to do first is I want you to simplify this on your calculator. Then after you multiply everything together and divide by 37, so 30 times the sine of 68 degrees divided by 37, then you say second and put all of the decimal places into your calculator. So let's do that. 30 times the sine of 68 degrees divided by 37. You get 0.75. So you get, on the inside, you get the inverse sine of 0.75177. Okay, well, all I do is plug that into my calculator, second sine, and plug in that answer. I get the measure of angle B is going to be equal to 48.744 degrees. Make sure your mode is in degrees, and make sure you said 30 times the sine of 68 divided by 37. That gave you your answer for angle B. Are we done? No. We solved for angle B. Now we have to see if we can solve for angle C and side C. So if we have angle B to be 48.744 degrees, how am I going to solve for angle C? Well, if I have two of the angles in my triangle, can I solve for the third angle? Yes, I can. Let's just do that over here. I think you guys just say yes. The measure of angle C is going to be equal to 180 degrees minus the sum of my two angles, 68 degrees plus 48.744 degrees. And what does that give you? 180 minus that will give you the measure of angle C, which is going to be equal to 63.256 degrees as the measure of angle C. If I have the angle C and I'm missing its corresponding side, but I have angle A and I have its corresponding side, can I find the missing variable? Yes, I'm going to use the law of sines. So let's do that. Law of sines tells us that the sine of angle A, 68 degrees, divided by side A, 37, is going to equal to the sine of angle C, which we just found, as we said it was 63.256 degrees, divided by side C. Okay? So, now all we do is we solve for our variable. We solve for our variable. I'm going to go ahead and erase this just so you can see. Just so you can see. Funny. Anyway, I'm solving for C, so multiply by C on both sides. So we got C times the sine of 68 degrees divided by 37 is going to be equal to the sine of 63.256 degrees. How do you solve? You multiply by 37 on both sides. And after you do that, you're going to have C times the sine of 68 degrees is equal to 37 times the sine of 63.256 degrees divided by the sine of 68 degrees divided by the sine of 68 degrees. C is going to be equal to 37 times the sine of 63.256 divided by the sine of 68 degrees. Let's do it. You get the side value for C equal to 35.637. So you should have gotten 35.637. Alright, so we've solved for everything that we need to know, and that is the end of that problem. So we are good to go. So now turn to the next section, section number 6. So we just, in this problem, before we turn to the next section, what we did is we used the law of sines to figure out the missing information. And we knew our basic geometry of the sum of the triangles always adds up to 180 degrees. Yeah, that's about it. We were able to use the law of sines because we know an angle and its corresponding side. And if we knew another angle or another side, we would have been able to figure out the other missing piece using the law of sines, which is exactly what we did. Cool. So in this problem, I worked it as 68 degrees. The actual problem says 86, and I just realized that. I guess I was dyslexic for a minute. But yeah, if you work it with 86 degrees, you're just going to get different answers for your angles. But I worked it with 68 degrees. I guess that's how I saw it for a second. So go back and rework it if you would like to work it, or you can change it to 68 degrees if you're watching this video. So, now the problem that I want you to take out is the application problem number 1. So application problem number 1 for station number 6. So I'm going to read it, and then I'm going to draw up a diagram because so I'm going to read it, and then I'm going to put up a diagram to show you exactly what you need to do. So here's the problem. It reads, a radio antenna 85 feet high is located on the top of an office building. At a distance AD from the base of the building, the angle of elevation to the top of the antenna is 26 degrees. The angle of elevation to the bottom of the antenna is 16 degrees. Find the height of the building. Okay, so let's work it using what we know from the law of sines and the law of cosines. First of all, we have to draw all the triangles that we see. So we're going to draw all the triangles that we see. So if you look at your diagram on your page, you'll see that you see 3 triangles. So triangle 1, triangle 2, and triangle 3. And notice that these triangles are just like the problems that we were working, except now it's a little more challenging. They're tilted on their side. So just imagine it tilted on its side whenever you're drawing your triangles. So triangle number 1, I'm going to say it's the bottommost, well, it's the topmost triangle. That's what I'm going to label as triangle number 1. It's the smallest triangle. Okay, then triangle number 2 is the triangle that's right underneath it. Well, we're looking for the height of the building, and this is the height of the building on triangle number 2. And then the overall triangle, which is the biggest triangle. So another piece of information that you need is that the building is 90 degrees with the ground. Okay. So now you have to label everything that you know that you're given. So you know that this angle from the ground to the bottom of the antenna is 16 degrees. You know that from the bottom to the top of the antenna is 26 degrees. So from the bottom of the antenna to the top of the antenna has to be 10 degrees for this angle. Then you also know that you're looking for H, which is right here. And you also know that from the bottom of the antenna to the top of the antenna is 85 feet high. So now what we're going to do is we're going to label all the other things that we don't know, just so we can keep track of the letters, and so we don't draw diagrams that are just so we don't make calculations that we have no idea what we're using variables for. So let's just label some of these angles. So this top angle in triangle number 1 I'm going to label as angle A. The side across from angle A I'm going to call side A. Well, that side A is connected to the hypotenuse in triangle number 2. So it's the exact same side. Alright, so that's side A and angle A. So what else do we need to know in triangle, or what else we don't know in triangle 1? Well, I don't know this angle. I'm going to call that angle B. And across from angle B, let's just say that's side B. Well, side B is the overall length of the triangle, the big triangle. Alright, so what else do we know? Well, as I said, if you tilt your diagram onto the side, you'll see that in each triangle, you're going to have another angle